So here's the problem. We're going to be putting eggs in something like this. We'll probably have I don't know, some weights. I'm not going to tell you how much, but we'll attach some weights to this thing. And the egg is going to stick out right here. The other end of this is going to be attached to a hook that's up on the ceiling. And as you can see here, we're going to hold it like this so that the bottom of this bungee is even with the other top of the bungee right there, and then let it go. And this is going to go down, 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 and then bounce back up. At its low point, somewhere below the low point, you're going to position a ceramic tile. Here's the ceramic tile, and get it as close as you can to the egg without the egg breaking. And you're going to get to do two different positions, but you have to specify where the tile is going to be on both of your drops ahead of time. So you'll probably want to choose maybe a conservative position so that you definitely won't hit the tile, and then you choose a closer one for your second try so that you can get as close as possible. And if your egg cracks, you lose. Alright, so some clarifications about this. This is the bungee hanging here. This is when it hasn't been stretched at all. And when the egg contraption falls, it's going to fall this far before it ever starts stretching the bungee. When it gets to this point, or when the top of this, when this reaches that point right here, it's going to start stretching, stretch, 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 and then stop. And then I'm calling this the final egg distance from the floor. So what you're going to be doing is hooking weights on this and then measuring basically how far this bungee is stretched, as well as what the weight is to stretch it that far. And that's going to allow you to calculate how much work is being done on the bungee. And essentially, when the potential energy lost by this falling bungee jumper equals the work that's being done stretching the bungee, that's when it stops. Let me go to my spreadsheet. Ooh, spreadsheet's on a different... No, I opened up the wrong one. Sorry. Okay. Need to make sure... This says answers to homework bungee jump. Well, just disregard that title. I'm going to be giving you a blank version of this, and I'll explain how to set it up later, but for now I just want to show you how it works. So this is the hook to floor distance, and hook to floor distance is this, from the bottom of the hook to the floor right there. The bungee jumper total mass, that would be the mass of all this stuff, whatever we add to it, plus the egg, not including the bungee itself. I wonder if you should include the bungee itself. I don't think it's really relevant. The fall distance before stretching the bungee, that is this distance right here. And it's orange just to show you that that corresponds to this. I'll come back to that later. The distance the egg hangs below the bungee would be measured from right here to the bottom of the egg. And that's important because you're going to be doing all these calculations about how far the bungee stretches, but then the bottom of the egg is going to hang this much lower, and you need to think about that when you place your tile. So these two, these are This is from the graph, which I'll get to in a second. So I got this. I just typed this number in here, 0.092, from my graph. And this number is the final distance of the bungee from the floor minus the height of the egg. So here's the final distance of the bungee from the floor.
Oh, I knew it when he moved here. I knew it.
Final distance bungee from the floor, which if you then subtract the distance the egg hangs below the bungee, that's the final egg distance from the floor. Alright, so how this works. I've got bungee distance from the floor, 8.44, 1.695, 1.4. These are all decreasing, and that's because those are measurements of this, and then we add a weight, and this gets a little bit closer to the floor, and then we add another weight, it gets a little bit closer to the floor, add another weight, gets a little bit closer to the floor. The other bits of data across from that are the hanging mass. So no mass, it's this far from the floor. 0.1 kilograms or 100 grams, that far from the floor. 200 grams, 0.2 kilograms, is that far. So I'm just adding weights and seeing how far it stretches. Now it's, I think, a good idea to take the weights off every time, because if you just let the weights hang on here, this bungee is going to get all stretched out, and it's going to get looser. And when you actually drop it, you're going to give it a chance to recover a little bit, and then when you drop it, it's just going to be pulled once. So I think it's better to just put the weights on, measure the distance, take the weights off. Put the weights on, measure the distance, take the weights off. You can do it however you want, but that's what I'd recommend. Now, total stretch distance, right here you can just see it's A7 minus A8. So A7, that's the original distance from the floor, and this is the new distance minus the original distance. So it's been stretched 0.149. And this 0.444 is 1.844 minus that. And this 0.744 is 1.844 minus that. So this is how much it's been stretched. This is the force of the hanging mass. So this is the hanging mass. The force is the weight of the hanging mass. I could put weight in there. And that's just mass times g. So 0.98 is 0.1 times 9.8, and 1.96 is 0.9 or 9.8 times 0.2. So now we have a distance stretched and we have a force. And now come the work intervals. So this is complicated. Basically, for each interval you do the average force times the length of the interval. So this is the amount of work done with the average of these two forces times the distance from here to here. That's the work done. This is the average of the two previous forces times the distance from here to here. This is the average of these two forces times the distance from there to there. So this is the work done in each interval. And then finally, this is a running tally of the total work. So 6.22 represents all these added together. 3.91 represents these added together. So this is the amount of energy done stretching the bungee. And on a graph, that looks like this. I have it graphed in kind of a strange way. This is the bungee distance from the floor. And you can see there's the most, this red is the work done stretching the bungee. There's the most work done when the end of the bungee is close to the floor, which makes sense. So chronologically, over here on the right, this is where I started, and far from the floor, and then I worked closer to the floor. And there's more work done as the bungee gets stretched. Now this other graph, this is the potential energy lost by the falling object, or the jumper in this case. Let me go back to this first sheet. So I've got a first column which is exactly the same. This is exactly the same as this. These are bungee distances from the floor. So by the time the bungee gets to this far from the floor, or let me switch to my picture, it'd be basically right here. This is the 1.8 meters in my just made up numbers that I've got there. It will have already fallen this far. So this is 1.8 whatever. This distance that falls before that is just the total height minus that minus the distance from the floor. So it's 1.27 B1 minus A7. It's hook to floor distance minus the starting distance from the floor. And that's what all these numbers are basically. They're the total ceiling height, or the hook to floor distance, minus how far the bungee is now from the floor, and they represent the distance that it's fallen. So the jumper has fallen 1.2 meters right here when it first starts stretching things, and it continues to fall farther and farther. And then the potential energy it's lost is equal to the distance it's fallen. That's height times its mass times g. So this is just mgh. So here we go. So this is the energy that, if we, again, chronologically, it's going right to left. It's falling, it's losing more potential energy, and energy is being stored in the spring more and more and more. And right here, if I can change the scale of this so I can zoom in, but it's about 0.092 distance from the floor where these two cross. And then all the potential energy of the falling jumper is stored in the spring. Everything stops there for a second. Well, not for a second. Stops there before going back up. So I used my graph that you just saw to get the number 0.92, which is right around here. And then I put that in here. So 0.92, again, is where the end of the bungee is going to be. This would be my 0.92, or 0.092 in this case. But that's not where the end of the egg is going to be. I need to take this distance and then subtract the so-called distance that the egg hangs below the bungee. So 0.092 minus 0.09 gives me 0.002. If everything is correct here, this egg's going to come it's going to be 2 millimeters from the floor before it bounces back.